All right, welcome kids. This is Mrs. Morgan. This is our first lesson through a video, and then you'll have a Pearson assignment to go along with this. So we just finished up all of our geometry, our cereal box activity, so we're finally done with that. All of your grades have been updated, and they are put into RDS, except for the one that is due today, February 13th, or sorry, April 13th. Goodness. So if you have any questions on any of your past grades, please reach out to me. Don't hesitate. I am available. So our next few lessons are going to have to do with scatter plots and how to collect and organize different data. So what is a scatter plot? A scatter plot is a graph that is used to display numerical data. This notes that I am doing right now, they are in Shobi, so you can see I am writing on them, so it will save and you will see the information here. And then you can also pull back this video. You can find it on Canvas. So we're dealing with numerical data, meaning data that has to do with numbers. We can't ask a question on what's your favorite food, because that answer doesn't have to do with a number. Now, if I counted up the students in the class, how many students liked pizza best, and how many students, the number of students that liked steak best, and we compared the numbers of students, well, then that would be numerical data. All right, and there's two variables, so there's two things that we are dealing with, and what we call that is bivariate data. Bi meaning two. And there's your bi. So scatter plots can help determine if one variable has an effect on the other. So then we can look at, is there a pattern, is there a trend, or we also call this association. All of these are the exact same terms, and we'll also call it correlation. So you'll see all of those words used interchangeably. So three different types of associations. We have positive, negative, or no association. So positive, think of what we learned in slope. If you look at this scatter plot over here, you see basically a pattern that's going uphill from left to right. So it has a positive slope. So that's how you can find it on the graph. Two variables have positive associations when the two variables move together. Oh, my pen's not working here. Meaning both of them are going in the same direction. So if something increases, then the other variable also increases. Okay, so the negative association, if you look at the graph, again, like our slope, the pattern is going downhill. What I'm drawing here we call trend lines, which we'll get into next week. So variables that have negative associations are when the variables move in opposite directions. So for example, as one variable increases, then the other variable goes the other way, it decreases. Okay? These associations we can look at in examples without even seeing the graph, and we can think about, so if one side is increasing, what's happening to the other side? Okay, or the other variable. A no association, if you look at the graph, there's no pattern there. We can't see that there's an uphill or downhill trend. There's just kind of points scattered all over the place. So that's a no association. So now we're going to describe some associations that we'd expect to see. We don't see the actual graph. So A here, the hours a person studies and the number of states they've visited. So let's think about this. If a person studies more, is that going to affect the number of states that they're visiting? So if you spend a lot of time studying for your math exam, is that going to make any change on how many states that you have visited in the past? No, it's not going to do anything. So that is what we call a no association. I apologize, my handwriting's not the best on here. B, the next one. So the hours a person studies and their grade on the exam. So if the number of hours goes up on that you're studying, what do you think is going to happen to the grade on the exam? obviously we're hoping that the grade goes up as well. So both of these things are increasing. So as you increase the number of hours you study, well, then you're also increasing the grade on your exam. So that goes back to our increasing one variable. One variable increases, the other variable also increases, so that would be a positive association. Oops, I'm sorry. There we go. Okay, and then last example here, the number of hours a person studies and the hours they spend watching TV. So if you're studying, the hours a person studies, if this is increasing, what's happening to the hours that you're spending watching TV? Hopefully, the hours you're spending watching TV is going down because you're focusing on your studying. So you notice these two things are going in opposite directions. You're increasing the hours you're studying, so then the amount of time on TV is decreasing. So opposite directions, that would be a negative association. Okay, so there we could figure out associations without even having a graph. Now, we can also look at, in those associations or in those correlations, trends, what kind of shape is being drawn. Is it a straight line or does it kind of take a curve pattern? Are the points really close together or are the points kind of further apart, not as great of a pattern or association? So, for example, if a straight line can be drawn, well, we've talked about this word several times this year. Oh boy. A straight line is what we call a linear association. So if it is not a straight line, then we call that non-linear. All right, if the points of data are really close together, then we say that this is strong because it is very consistent. So this is a strong association. If the data is more widely spread out, then that's what we call a weak association. Okay, and I think when I was deleting some things here, I deleted the answer for this, the negative association. Okay, so we're going to look at all these examples down here at the bottom and identify, do they have a positive, negative, or no association? Are they linear or nonlinear? And then is it a strong or a weak association? Okay, so for this first one, is it going uphill, is it going downhill, or is there no pattern at all? Well, kind of similar to what we looked at in that positive association, it is going uphill in our slope. So we have positive. It does form, you see I drew a line there, that is a linear, oops, I was trying to keep my colors consistent with up above. So a linear association, and then for me they're pretty close. I would say all those points, if you look at our line, they're all pretty close to the line. They're not too far away. So I'm going to call that a strong association. So it's a strong linear positive association. Okay, next one, again, you notice there is a pattern. It is going uphill. So we're going to say that is positive again. Again, it has a straight line pattern to it, so we're going to call that linear. Now notice the points on this one, they're a little further away from that line. They're not as close and together as this first example, so this is an example of a weak association. Our points aren't as close together. Okay. Next one, so back to positive, negative, no. Well, it is going uphill, so that is a positive association. But notice in this one, it's not a straight line. It didn't look like our first two examples. It now has a curve to it. So this one we call a non-linear association. All right. Again, those points are pretty close to that line, that non-linear line that I drew. They're all pretty consistent, so we call that a strong association. Okay. Here now our pattern changed because now it's going downhill, so that is our negative association. I just drew the straight line, so we are going to call that linear. And again, those points are pretty close to that line. They're all consistent, so we'll call that a strong association. Okay, here is then an example. If we draw our pattern, again, it is going downhill, so it is a negative association. However, in this example, it's not our straight line, so this we call non-linear. And then this one, the points aren't as close and congregated together like example 4. So this is an example of a weak association. All right. And last one, here's an example. We can't really draw a line. There's no exact pattern. It's not going uphill. It's not going downhill. This would be a no association. All right, since we can't draw that line in there, this is non-linear. And then since those points are scattered all over the place, there's no consistent pattern, we call that weak. All right, so we got that first page filled out. Hopefully you can identify if you are given a scatter plot, does it have positive, negative, no association? Is it a straight line or non-linear? Or are they congregated close together? Is it strong? Or are the points more spread out? Is that weak? Okay. Last thing we're going to do today is then actually construct a scatter plot. So before I started this, I already came in and I labeled my scatter plot. I looked at the information here. So Jared's basketball team stood at various distances from the basketball goal, and they counted the number of baskets they were able to make in 30 seconds, the distance each person stood from the goal, and then the number of baskets made is shown in the table. So I went through, I looked at the distances and found that 28 feet was the furthest that anybody stood, and then 14 baskets was the most that anybody made. So I created my x-axis. I labeled those intervals by 2 so that I could fit 28 on the graph. And then I labeled my y-axis by 1s so that 14 would fit on there. And that way I can use the majority of my scatter plot. We don't want to make it shorten it all so that all our points are in one location. We want to try and use as much of the graph as possible. Okay, so we'll go through, let me change my colors here, and plot each of these people individually. So Jared stood at 14 feet. I'll go to 14 feet on the x-axis. And then 4 baskets made, so his point is right there. Tyrell, 25 feet, so I'm going to have to go in between 24 and 26. Right in the middle is 25. And then up he made 26 baskets. So there's Tyrell. 27 feet, again right in the middle of 26 and 28, and he made 7 baskets. 15 feet, right in the middle of 14 and 16, made 11 baskets. Let's see, that was Mark. So CJ was 26 feet and 6 baskets made. So he's going to be awfully close to that other point there. Kevin, 16 feet and made 13 baskets. All right, Wade, 15 feet and made 12, so in between 14 and 16, go all the way up to 12. I'm kind of noticing a pattern here, if anybody else is. Kyle, 26 feet, 8 baskets made, so he goes here. Chris, 16 feet, and 14 baskets made. He's all the way up here. And Tim, 28 feet, 5 baskets made. So, let's see. We know that how many people are on the team? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have 10 little points then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I plotted them all. So there's our scatter plot. So in the end, let's look at our associations. Do we have a positive, a negative, or no association? To me, there's two little groups here. We see kind of a group here, and we see a group here, and there's not a lot in the middle. Let's think about why that would be. If we actually are thinking about the basketball team, and hey guys, let's go pick a distance, see how many baskets you can make. I am assuming that these 4 guys up top here, these guys are probably all buddies, and these guys are probably all buddies. Now this guy, he stood, you notice these are the distances that this group of people stood. So all these guys, these 4 and this one guy, they all stood about the same distance. Now this group of 5 people over here, they all stood about 24 to 28 feet. So it looks like the team kind of split up, and half of them went to one distance, half of them went to the other. And that is why we're missing points in the middle here. We don't have anything here. But if we followed the pattern, and let's just say these yellow points are going to be if somebody chose to stand in between at this 18 to 22 feet. Well, if we followed the pattern, they'd probably wind up in here. So if we added some points to kind of look at that pattern, well, now do you guys see that there's a negative association here? Okay? What that means is our 2 variables, the distance from the goal, the number of baskets made, they're going in opposite directions. So as you increase the distance, as increased distance from basket, well, obviously it's harder to make the baskets. So the number of baskets made goes down. So as increased distance from basket, number of baskets made decreases. Okay, so, oh, look at that. I was a step ahead of myself. So as the distance from the goal increases, the number of baskets made decreases. That is true. That's what we just talked about. Okay, as the distance from the goal decreases, so let's say we go the other way, as it decreases down here, the number of baskets made increases. Well, that's true too. All right, the 2 variables are going in opposite directions. So this last one, as the goal decreases, the number of baskets made decreases. So they're both decreasing. Well, that tells us that's a positive association. So that's false. Okay? Now, some other observations, I didn't list them all out here when it says list other observations. Well, we talked about kind of these yellow points, and those being the gap, so nobody stood in that distance. So that was an observation we saw as well. So outliers. Okay, outliers are a point that does not fit in the overall pattern or trend of the data. Uh-oh, my pen won't work here. Wonder what happened. Oh, there we go. All right, so pattern or trend. So hopefully you guys could see that there was an outlier here. So our outlier is this guy right here that I'm circling in orange, because he did not fit in the overall data. So who was that outlier? So 14 feet, 4 baskets made. Oh, that was Jared. All right, so Jared was the outlier. And that was because he just didn't make as many as the rest. So he stood a similar distance as his teammates, but didn't make as many. And I apologize. I'm not used to writing on the iPad, so it's a little challenging, but I think you guys are getting the overall gist of it. All right, then clustering are these green circles that I made earlier. These are the clusters, those groups of kids that stood together. So a cluster occurs in a scatter plot when there are distinct or separate groups of points. Okay, why do you think clustering occurred? Well, we talked about that there were basically two groups that chose similar distances. All right, hopefully from the basket. Hopefully all of that made sense. The Pearson Realize, obviously you can use the question help. There are videos in Pearson. And then these notes you have in the video, you can always refer back to this. All right. Hope all of you are staying healthy and strong, and that your family is healthy as well. I'm thinking of all of you, and we will have another video next week. I look forward to that. See you later.